Good morning to all. Welcome back to our channel Physics Gallery, Asha Vinu. And we were discussing our resolution of a vector. Okay. So, is there any doubt in the previous classes? If there, please ask it in the comment box. Otherwise, how can we solve it? So, we were discussing the resolution of a vector. How to resolve a vector. That is, suppose a vector A is given. Suppose a vector A is given. This vector may be resolved into two rectangular components, two perpendicular components. And for that, we have said that take the starting point as the origin of the vector, plot x and y axis from it, perpendicular axis from it. Now the vector is in first quadrant. In the next step, take the ending point and take two perpendiculars which meets to the perpendicular axis and put arrows in such a way that it always originates from the origin. Okay, so we can say this much is the x component of vector A and this much is the y component of vector A. Okay, clear? And when another vector B was taken, the second vector B was taken, then also we had taken the same process, that is taking the starting point as the origin, plotting x and y axis from that. In the next step, from the ending point of the vector, we have taken two perpendiculars to the given perpendicular axis, two perpendiculars to the given perpendicular axis, putting arrow starting from origin and taking this much length act as the two perpendicular components of the vector. This is the x component because it lies in the x-axis, and this is the y component because it lies in the y-axis. Clear? Then we have taken the third vector, vector C, like this. How to take? Here also the starting point. This is the starting point of the vector now, which acts as the origin. From that origin, we have plotted the x and y axis like that. Okay, then thereafter, from the ending point, we have taken two perpendiculars. Okay, all of these things were studied in the previous lecture. Putting arrows in such a way that arrows originate from the origin, and this acts as the x component of the C and this acts as the y component of C. Okay, one more vector we have discussed. May I draw here? This is the vector D. Then the same procedure, take the starting point of the vector. Are you studying? Are you listening? Already we have discussed it. Taking this point as the origin, plotting x and y axis from the origin. Now the D vector is in the fourth quadrant. Taking the endpoints, then considering two perpendiculars from the endpoints to the perpendicular axis taken, then putting the arrows in the same way as that they originate from the our origin. Okay, so we can say this much is the x component of vector D and this much is the y component of vector D. Okay, so already we have discussed how to resolve. In the same way, suppose a vector is given like this. Vector E in the x-axis. Then how can you resolve? How can you this vector is resolved? For that, we have to take two perpendicular components. It is not at all necessary that perpendicular components always reside in x and y axis. Here it is easy to take the x and y axis. That's why we have taken it into C, x and y components. But now the vector itself is in the x-axis. So how to take? That is, the taken axis is rotated. That is very simple. You will draw a line passing through the starting point. Okay. In the next step, take a perpendicular line to the first drawn line. Then the same procedure. At first, you have to draw a line passing through the origin, passing through the starting point of E. Then take another line which is perpendicular to the first line taken. Then resolve. Put perpendiculars from the ending point like this. Okay, now this much is one component, this much is the second component. But never take it as x-axis because it is not in x-axis. Take it as E1 and E2. The two vectors are now, two component vectors are now E1 and E2. You can resolve a vector in any axis into two perpendicular components. Similarly, suppose a third vector, a next vector is in the y-axis like this, My F vector is in y-axis like this. How to take two perpendicular components of this F? Tell me. Take this point as origin, plot a line, not x and y, but a line passing through that origin, and the second line must be perpendicular to the first line drawn. Okay, these two lines will be perpendicular. Over, then ending point, from that ending point, take two perpendiculars to the taken axis, put arrow in such a way that these arrows also started from the origin or the starting point of the vector. This much will be one of the component of vector F. This is the second component of vector F. Okay. So any vector can be resolved into two perpendicular vectors, two rectangular components. Clear? Perpendicular vectors. So this topic is already taken in the last class. But here the importance is, this is the method, the first step how to draw these vectors. But later we never go to like this x-axis, y-axis and so on. At first you pause the video and plot this much of topic. Okay, hoping you have completed. Now, listen. It is the initial step how to explain the resolution of a vector, how to take two vector perpendicular components. Vectors, perpendicular components. But now onwards, we don't have to take the x or y axis like this. We can simply draw that. For example, our first vector was vector A like this. This is our first vector. Okay. How we have taken the A, x and A, y components? We have taken this starting point as the origin. Plotted x and y axis. From the ending point, taken the perpendiculars like this. Now, that was the method to explain how a vector is resolved into its perpendicular components. But now we know how to resolve what are the perpendicular components. So, now onwards, don't take x or y axis, simply take the components. We know both of the x and y components must start from here. So, take a line to the x-axis. Up to which position? Up to this end. Okay. This much distance to this end. You have to take the x line to this end and put arrow and take it as x component of vector A. Clear? Similarly, take another line which is perpendicular to x, that is y. Up to which point? Up to this tip. Not extend or not take a lower line. Always take this arrow up to this tip. Okay. Then take it as AY. Clear? Clear? How to take the x and y components directly? Next example. We have taken the second example, vector B like this. This was the second vector. So how to take the two perpendicular components of this vector? This is the starting point. From the starting point, whether you draw a line towards right or left, the vector may be included in a 90 degree. Therefore, whether you draw towards right or left, tell me, the x component, whether it exists on right or left, surely it exists on the left end because this is the end point. Up or down, the y component up or down, surely it is up component. Okay, then only the two components resides this vector in a 90 degree. That is, this is bx and this is by. Clear? The third vector, vector C was given like this. This is vector C. How to take the x component, right or left? Tell me. Yes, surely towards the left up to this end. Up or down? Surely towards the down up to this end. This is the x component of vector C and this is the y component of vector C. Okay, then what about the fourth vector? This was our fourth vector D. How to take the two perpendicular components? The x component, whether it is towards right or left? Yes, surely towards the right end. Whether it y component is towards up or down? Surely it is towards down, dy. Okay, clear? Next, suppose our vector E is in x-axis itself. This is vector E. How to take now? Take one of the line up to this end like this. And the second line perpendicular to the first line so that its end comes almost to this point. Okay, this much. This is vector E. This is one component of vector E. This is the second perpendicular component of vector E. Clear? Okay. Similarly, the sixth one. Suppose our vector is in y-axis. F. How to take? Take one of the component like this. This is one of the component up to this end. And the other component will be perpendicular to the first line taken to this end. To this end. Take one as F1. Take other as F2. Clear? Clear. So now onwards, never take origin, x-axis, y-axis and so on. You have to resolve a vector like this. Okay. Pause the video and take the notes of this much topic. Very important resolution of vector. Without resolving a vector, we cannot go through any of the physics chapters. Because in every chapters, there will be some vector quantities which we have to resolve into two components. Either in x or y axis or in any other axis like this. Okay. So, hoping you have paused the video and taken all of the lines or diagrams. Okay. So, hoping all of you now know how to take resolution of a vector. That is how a vector is resolved into two perpendicular components. Either towards xy axis or to other perpendicular axis. Okay. Once more, I am going to take the vector A. This was our first vector A. Vector A. Okay. And which are the two components of vector A? Tell me. Yes. The first component towards right or left? Surely towards right up to its end. The second component up to up or down? Surely it is up to this end. This is x component and this is y component. Are you getting, dear students? Do you understood? Yes. Now, suppose in a question it is given that vector A makes an angle theta. Vector A makes an angle theta with our x-axis. Vector A makes an angle theta with x-axis. Then, listen. Suppose I am completing this triangle. We have got a right-angled triangle. In that triangle, may I take sine theta? What is sine theta? Sine theta is always opposite side by hypotenuse. Opposite side by hypotenuse. And which is the opposite side now? This line is the opposite side, which is surely parallel to AY. This side is parallel to AY. So we can say opposite side as vector AY. Okay. Divided by hypotenuse is our vector A. Okay. I am always towards the board. So it doesn't mean that you have to get out from the class. Please listen. Okay. So sine theta is opposite side by hypotenuse. Opposite side is parallel to AY. So this is AY itself, vector AY, by hypotenuse is vector A. So that we can write AY is equal to vector A cos theta. AY is equal to vector A Sorry, sine theta. We have taken sine theta. So AY is equal to A sine theta. So what is the magnitude of this vector? AY. What is the magnitude of AY? AY is equal to A sine theta. Clear? Okay. Similarly, taking cos theta, adjacent side by hypotenuse. Now adjacent side is AX. By hypotenuse is vector A itself. Or we can write the x component of vector is vector A into cos theta. That is, taking cos component of this A cos theta, you will get AX. Taking A sine theta, you will get AY. Okay, how to take the magnitude of this components? Here we got the x component as the cos component and y component as the sine component of vector. But whether it is always as such, whether x is always cos component and y is always sine component, we have to look on that. For that, I am taking the second vector. Resolve it. Right or left? Left. Up or down? Up. Okay. Suppose now the given angle theta is, in the question it is given that the vector B makes an angle theta with the y-axis. Then this is the x component and this is the y component. Take the triangle here, right angle triangle here. Now taking sine theta. Which is sine theta? Opposite side. This is opposite side, which is parallel to x component. Bx by hypotenuse is B itself. That is, now we got Bx as the x component as the sine component of main vector B. Similarly, taking cos theta. Cos theta is equal to adjacent side. Which is the adjacent side of the triangle now? By. By by B. That is, by, the y component of vector becomes the cos component of the main vector. Okay, here we got x as cos theta, A cos theta. Whereas here we got the y component as B cos theta. Here we got y component as sine theta. Whereas here we got the x component as sine component of the main vector. So how can you understood that? How can you understood that? The simple ways. This is angle theta and AX is nearer to angle. It is in contact with the angle. Okay, AX is in nearer to angle theta or it is in contact with angle theta. Whereas AY doesn't touch us with the theta. So we can say if a vector, component of a vector is in contact with the angle theta taken or it is nearer to the angle theta taken, then it will be nearer, adjacent. Adjacent component is always cos component. So if component is nearer to angle theta, that will be the cos component of main vector. AX is the A cos theta. If a component is not in contact with the angle theta, whether AY comes in contact with theta? No. AY is opposite to angle theta. Clear? The opposite component will be the sine component. Adjacent component will be cos component. Opposite component will be sine component. Here AX is adjacent to theta, A cos theta. Here AY is not adjacent, not in contact with theta, so it is sine theta, A sine theta. Look here. This is angle theta and which component is in contact with angle theta? By is in contact with the theta. Therefore, we can say By is equal to B cos theta. Adjacent component is always cos component. Whereas Bx is opposite to angle theta. It is in not contact. It doesn't comes in contact with theta. Therefore, we can say now Bx is equal to B sine theta. Clear? That means a component which comes in contact with the angle theta taken will be the cos component of the main vector, and a component which never comes in contact, that is which is opposite to the angle taken, then we can say it is the sine component of the main vector. Pause the video and draw this much. Pause the video and draw this much. Okay. Hoping all of you have taken this much of notes. Now we understood. A component which is nearer to the angle is the cos component and a component which is opposite to the angle is the sine component. That is, suppose this is vector A. Vector A makes an angle theta with x-axis. Suppose this is vector B. Vector B makes an angle theta with y-axis. This is vector C. Vector C makes an angle theta with the y-axis. This is vector D. Vector D makes an angle theta with the x-axis. It is given, suppose. Now, suppose this is vector E. Vector E. Suppose this is angle theta. And this is vector F. And suppose this angle is theta. So how can you resolve all of this? Come with me. So how to take? A is resolved into AX and AY. Correct? Okay. What is AX? Angle nearer to AX. That is, it is the cos component of vector A. And AY is opposite to angle theta. We can say A sine theta. Clear? Similarly, vector B may be resolved into up and left. This is the x component and this is the y component. Tell me, what is dx? Dx is B opposite sine theta. Whereas here, adjacent B cos theta. Clear? How to resolve C? Down and left. This is Cx and this is Cy. Okay, nearer Cy, C, we can write here. It is equal to C cos theta. Opposite to angle Cx, C sin theta. Clear? This can be resolved into two like this. Okay, this is the dy and this is the dx. Dx nearer to theta, d cos theta, and dy, d sin theta. Clear? Now, this is angle. So, take one of the vector like this, E1, and take the other vector like this. Okay, E1 is equal to angle adjacent E1, E cos theta. E1 is equal to E cos theta. What about this? E2 is equal to E sin theta. Not nearer to angle theta. Now, this one and the second one will be perpendicular to this. Okay, clear? So, take this as F1. If this is F1, this is cos component of the main vector. And if this is F2, this will be F sin theta. Okay, so how to take the components? Clear? Please draw each and every vectors and take the components one by one and analyze. Understood this? Okay, hoping all of you understood how to take. Clear? Okay, so very important. Resolution of a vector is very important topic for us. Very, very important because each and every chapter there will be some vector, force vector, acceleration vector, displacement vector, and every chapter there will be some vector like momentum, torque, and so on. Okay, so we have to consider the vectors and resolution of vector in most of all of the chapters in +1 and +2. Okay, that is okay. So vector may be resolved into ax and ay. Since this angle is theta, this is a cos theta, and since this angle is theta, this is a sin theta. Okay. So vector A is resolved into x and y components. X component is represented by putting I cap. What was I cap? Orthogonal unit vector along x-axis. And j cap may be represented as ay may be represented by putting j cap. That is, A is splitted into ax and ay. I cap and j cap refers that ax is in the x direction and ay is in the y direction. Okay, ijk refers x, y, z axis. If 8 can be split up into 5 and 3, then 5 and 3 on addition, we will get 8 also. 5 and 3 on addition, we will get 8 also. Similarly, If A can be resolved into AX along I cap and AY along J cap, we can say AI, and that is AX and AY on addition will give A. Okay, so what is the modulus of vector A? Resultant are root of A square plus B square plus 2AB cos theta. That is AX square plus AY square plus 2AX AY cos. What is the angle between the two vectors taken added? X and Y are 90 degree apart. What is cos 90? Cos 90 is, do you know, it is 0. So we can take vector A as root of AX square plus AY square. Okay, addition of vector. Similarly, how to take the angle tan? This angle is given as theta. Tan theta is equal to, how to take opposite component AY sine the angle between them 90 by AX plus AY cos 90, where 90 is the angle between AX and AY. So sine 90 is 1. It becomes AY by AX. Since cos 90 is 0, this term becomes 0. Do you understood this topic? If not, you have to type motion in a plane, addition of vectors, analytical treatment. You will get all of these equations. That is, if A can be resolved into AX and AY, surely we can add AX and AY giving vector A, obeying the law of cosine and also the angle taken tan alpha, tan beta, etc. Hoping all of you understood this. If not, please go to the previous lectures, then only you will get that. Okay, that is addition and resolution or reverse process. On addition two vectors, a single vector is obtained. On resolving a vector, again two vectors are obtained. Component vectors are obtained. Okay, so you can take this also. Why here angle theta is 90? This is not theta. Now this is, when we take this equation, you have to take angle between the two vectors which you are adding. Here AX and AY are 90 degree apart. That's why here in this equation and in this equation, this is addition process. Just showing that addition and resolution or reverse process, we have taken this. Okay, so we have completed almost our resolution. So how many perpendicular components we have got? We have got 3. We have got 2 perpendicular components. But how many perpendicular components are possible? 3, because how many axes are there? 3 perpendicular axes, x, y, z. Okay, but we have taken only 2 perpendicular components. Why? Because our chapter's name is motion in a plane. What is the chapter's name? Motion in a plane. So we have to take only 2 perpendicular components. Okay, but we can take up to 3 perpendicular components for a vector which is in space, 3D vector. Just for showing that, suppose we have taken a cubic space, this much of space. Okay, this much of space. May I take a vector? A vector A. This is my vector A. Can you assume the cube? From this corner to this corner, it is projected outside. It is projected outside. It is not in the plane now. From this corner of the cube to this corner, that means it is projected outside. This vector may be resolved into 3 perpendicular components. The first will be along x-axis. Okay, AX. The second will be along the y-axis, AY. And the third will be along the z-axis, AZ. Can you see the vector A? This is our main vector now. This is our main vector now. Okay. This vector A, can be resolved into AX. Can you see? AX, AY and AZ. Suppose this angle A makes an angle alpha with vector x-axis. Then it makes an angle beta with the y-axis. Suppose just taking example, and it makes a gamma, alpha, beta, gamma with z-axis. Can you see? Vector A makes an angle alpha with x, beta with y and gamma with the vector A and AZ gamma. Then we can write here, this vector A can be resolved into AX I cap plus AY j cap plus AZ k cap. Three vectors, three perpendicular vectors are there. Or AX is equal to A cos alpha, adjacent component, plus AY is equal to A cos beta, adjacent component, plus AZ is equal to A cos gamma. Okay, A cos gamma. Clear? Or modulus of vector A is equal to root of AX square plus AY square plus AZ square. We don't have to study the 3D vectors now because it is a topic from your maths. Okay. So just informing a vector can be resolved into three perpendicular components. This is shown. So today we are winding this video. Till the next class, study well, stay well. This is our channel. This is Gallery Arsha Binu. See you.